All right, we're back. All right. So I'm gonna talk about tangent theta. We're gonna graph that. One of the previous videos, I believe I did sine of theta and kind of overviewed on exactly how to graph sine and cosine of theta. And the end result was just simply just graphing sine of theta. But anyways, tangent theta works a little differently. These are those oddball functions: tangent theta, cotangent theta, secant theta, cosecant theta, and cotangent theta. I think I mentioned that already, but oh well, doesn't hurt to mention it again. So tangent theta, what is it exactly? Well, let's look at let's dissect it a little bit and see exactly what it means. For one thing, we know it is sine of theta over cosine of theta, right? So let me just describe that on the unit circle. So if I put that here and we said maybe this can be say pi over 6. I always like to use 30 degrees. Pi over 6, 30 degrees, same thing, just degrees or radians depending on what circumstance you're using them. So we know in the case of a triangle with the right angle that tangent theta, TOA, is opposite over adjacent, right? So opposite the angle, here's the angle theta over adjacent. Again, I like to go over this and really reinforce these concepts. So when we say this angle itself is 30 degrees or pi over 6 here, right? Then we know the side opposite here is 1/2, and here is root 3 over 2. By the way, I kind of made a big mistake in one of the videos. This is derived from an equilateral triangle, not an isosceles. Okay, so where all sides are equal. Isosceles triangle only has 2 of the sides equal. I didn't catch that until recent. Anyways, going back to this, tangent theta, right? And then we know this is a radius of 1, so tangent theta, so this is sine of theta equals 1/2. Tangent theta is root 3 over 2. That's cool, right? So we understand that. Now I'm going to step aside and not look at it so in such microscopic terms, but look at it more in a broader concept. For one thing, when you look at these angles as theta increases positive, so if we go pi over 6, pi over 3, 60 degrees, and pi over 2, 90 degrees, and then was it 2 pi over 3, which is 120 degrees, whatnot. I might have that wrong. Forgive me. Sue me. No, don't. I mean, I'm in debt already. So anyways, we know that sine is increasing. Remember that. That's a characteristic. Sine increases. And when you look at the graph of sine theta, it does increase. So we go from 0 to pi over 2, right? This is 1, negative 1, pi, 3 pi over 2, and then 2 pi, right? So it increases, then decreases, decreases, and increases again, right? Now if we look at cosine theta, given the same points and the same graph, we know that it starts to decrease. So at 0, it's its highest point, maximum, right? 2, 3, 4, and then decreases. So it's kind of so you're using these two different functions, sine theta and cosine theta, to describe tangent theta, and you have to work with that and from this perspective to understand exactly what tangent theta is doing, right? I gotta stop saying right. My mom checked out my videos. She said I say that word way too much. All right, so what are we talking about when it comes to tangent theta then? Well, first of all, we know tangent theta is a rational expression, function, right? Because we have a denominator, we could say that. So anytime that this denominator is 0, we know that this is undefined, so it's technically an asymptote, right? Just like if we know that 1 over x, when x is equal to 0, we have that asymptote wherever it may be, say x minus 4, 1 over x minus 4, then we know x equals to 4 is, or x cannot equal to 4, and x equals to 4 is our vertical asymptote, right? That's from polynomial or rational functions and expressions, but now we have trigonometric functions, and these rules still apply. It's mathematics, it doesn't change, right? So whenever cosine theta is 0, is when the graph is asymptotic, right? Asymptotic or something like that. So when is cosine theta 0? Well, we look at the unit circle, and remember cosine theta is x, right? So here's x. 0, it's 1, and then we even proved that using the or we've seen that using the graph of cosine, right? That at 0 it's 1, right, at the highest point, and then it starts to decrease. So it decreases and it reaches 0 at pi over 2. So that means at pi over 2, cosine of theta is 0. So tangent of theta is undefined, or it's asymptotic, right? And then we also know that cosine of theta is also decreasing from 0 to pi over 2, right? So there we go again, I'm saying it. So pi over 2, I'm going to use this, negative pi over 2, pi over 2 is, oh no, sorry you guys, I want to fit pi in there, pi over 2, negative pi. So let's try to put these on the graph a little bit more. Pi over 2, pi, oh no, what am I doing? This is pi over 2, pi, 3 pi over 2, and 2 pi. Let's see if I can do this quickly. So pi over 2, we have some type of asymptote for tangent theta, because again cosine of theta itself is 0, and that goes for 3 pi over 2, right? Because cosine again is 0, right? Okay, now, and then that also goes for negative pi over 2. Negative pi over 2 is just angles going in the clockwise direction. This is angles going in the counterclockwise direction, going this way. Now this is the clockwise direction, right? So we can kind of describe that, negative 3 pi over 2. So we have a bunch of asymptotes, and essentially that's what these graphs kind of encompass. They ensue these asymptotic ranges where you're going to go to infinity, negative infinity. Sine and cosine are the only ones that don't really do that. I mean, they have maximal points of maximum amplitudes of 1, negative 1, and whatnot. But you don't have really any, you don't have any asymptotes. Anyways, let's go back. I digress. So we know cosine of theta is 0 at pi over 2, and any multiple of that, right? Now sine of theta increases positive, right? So if sine theta is increasing positive, simultaneously we see cosine of theta decreasing. So we have sine of theta increasing, and just clock those points, 1/2, right? And at 45 degrees we have root 2 over 2 over root 2 over 2, and you can see them in the points. Root 2 over 2, our sine of theta is y, so they're equal right here. And then all of a sudden at 60 degrees, it's supposed to be 60 degrees, but no. Okay. At 60 degrees, I'm not going to try to draw it and attempt that. At 60 degrees, all of a sudden we have, what do we have? We have these, we have this, this is root 3 over 2, 1/2. Then we have 1/2 root 3 over 2, right? And then 0, 1, right? So we see that our y's or sine thetas, you know, they're interchangeable right now. They're increasing, and then cosine is decreasing. So we have from 0 to pi over 2, it's, so at 0, tangent theta is 0 because why? Sine of theta is 0. So 0 over anything is a valid answer, or valid is a definite number, right? Or a number. Now we said it's increasing, but as you approach pi over 2 or 90 degrees, you start to get it starts to head towards infinity because you get sine of theta over 0, right? Anything over 0 is approaching 0 is undefined, or starts to go infinity, right? That's supposed to be an asymptote. So it's near. It's approaching near this asymptote, and it's rising to infinity, right? Okay, now what about in this quadrant? We know that, wait, let me make sure. Oh, so we know cosine of theta is negative, right? So negative cosine theta, or x, and positive sine theta. Well, you have to account for that negative, because here, once you cross this boundary, you're now at negative infinity, because cosine, any value for cosine is negative here. So you have a negative infinity, and then we said if cosine is increasing here, now it's if cosine is decreasing as theta increases from this quadrant, as it goes back down, everything is opposite. So cosine of theta is now increasing, sine of theta is decreasing. So here, cosine of theta is 0, but it's negative, right? And then we said cosine is increasing, so increasing negative. And then, that's horrible. So cosine is increasing and sine is decreasing, so the number is getting a smaller negative, right? I can't draw this, you guys. I'm really horrible at this. I don't know what happened. So it increases towards infinity, right? And then at pi, we still see that cosine is -1, but sine of theta is 0. So 0 over anything is just 0. It's neither positive nor neutral, and it's neither positive nor negative. It's neutral. So that's why you have 0 here at pi. And then here we have negative cosine of theta, but also negative sine of theta. So now you have two. You have to account for both negatives, which equal positive. So all the values here, tangent theta will be positive, right? But we also see that it's kind of a reflection right here that going from pi to 3 pi over 2, cosine of theta is decreasing, right? So as cosine of theta decreases, and then as sine of theta increases, this fraction gets larger. So it gets larger, and then because they're all positive, it gets larger positive. Oh man, I'm gonna just show you the graph at the end so you guys can get it. Alright? Cool. And then again, here we go. It starts to approach, cosine starts to approach 0 here, and that's why it veers, or it's drawn towards infinity here. Now, here, negative cosine of theta, negative sine of theta, sorry. Negative sine and positive cosine, right? So again, one negative, so the entire fraction or tangent theta is negative for all its values, right? And we are at negative infinity here, but we see that cosine of theta is 0, so it's negative infinity, and then sine of theta is decreasing as you move in the positive direction, right? Or counterclockwise. So sine of theta is decreasing, but at the same time cosine of theta is increasing until it reaches 1. So it's tangent theta is decreasing negative, right? Until it reaches a point of 0, where cosine is 1, but sine of theta here at 2 pi is 0. And then that continues on, and that moves on forever, and you kind of get this repetition here, this graph repeating itself, right? At pi, negative pi, right? So I'm just going to show you quickly. Oh, that's my website. I was fixing it up for you guys. Okay, TanX. There we go. This is what we're looking at here. Uh-oh. Here we go. That's exactly what we're looking at. Cool. So you see how multiples of pi over 2 and 3 pi over 2, negative pi. So all those are asymptotes essentially, and any integer of or multiple of say pi, 2 pi, all them, that's 0. Cool. Hopefully that helped. Hopefully I didn't confuse you anymore. Thanks, guys.